Aaron Faulkner is co-founder of TYCHON. Thanks for joining me today. It's great to have you here. I am hearing a lot of folks at this show talking about quantum computing, first time.
Yes.
It really is something that's top of mind. What's over the horizon after quantum computing? What are people starting to think about as the next phase of security?
Yeah, we seem to be at a point where people are talking about quantum in two regards. One is what quantum computing is going to bring to everybody in terms of being able to factor new problems, address computational efforts in new ways. But quantum computing also brings a new threat. And that threat is to classical encryption, where quantum computers can break what we've been trusting for decades. So things like RSA 256, the standards that have been in place since essentially the dawn of information technology. And as quantum computing becomes more available, right, becomes more of a commodity capability, that means that attackers are going to be able to leverage those resources to get after and find secrets, the things that we've been working to protect our entire careers in cybersecurity.
Is that because of just the raw compute power of quantum computing, or are there other factors involved?
Yeah, in its most simplest form, that's exactly it, right? Just the raw horsepower that it brings to the table. And previously, quantum computers only available to a nation state or some type of national lab. But now they're being used in commercial practices. We're seeing them used in healthcare use cases, in financial use cases. And of course, bad actors are going to start to use quantum computers for cybersecurity use cases and finding ways to break that classical encryption. And so what, federal departments and agencies have had mandates now since 2022. There was the Quantum Computing Preparedness Act that was passed, so there's legislation. M2302 speaks to quantum readiness. There's been national security memorandums about this saying, hey, the federal government needs to establish a cryptographic inventory, understand what your most vulnerable ciphers are, and find ways to prioritize, your and address your worst problems first, right? And so that's an area that we're working to help the federal government to efficiently determine what cryptography and encryption is in their enterprise. How can they start to migrate to quantum-resistant algorithms, which are now available? So NIST published quantum-resistant algorithms this past August and September, and those algorithms are finding their way into some of the commercial off-the-shelf capabilities, which is great. But as we know, in the federal government, there's a tremendous amount of legacy tech, and that legacy tech also that encryption needs to be upgraded to now quantum-resistant algorithms. And so we're focusing on that area to help our federal customers build that inventory faster.
Cyber practitioners have been trying to get ahead of the bad guys probably since there have been cyber practitioners. Is this an extension of that, or is this a different problem going in a different direction because of the nature of the horsepower, because of the nature of what needs to be protected, other factors?
Yeah, that's a great question. So I think in some regards, it is a new vector because quantum computing just wasn't available to the bad guys. But on the other side of the coin, it's really not that much more different than the same CVEs or common vulnerabilities that have been out there for decades and being published. And so you can start to think about cryptography being as similar to a vulnerability that Microsoft might patch on or push out on Patch Tuesdays, right? That we are now going to start to look at the encryption and cryptography in our environments in the same way that we would look at any other common vulnerability and start to report on that. So if you think of things like the CISA CDM dashboard, if we're looking at a vulnerability for a piece of software, we should probably start inventorying and looking at a vulnerability for particular algorithms and encryption in the environment.
We have about a minute left. As the organizations, particularly in DoD, that we're focused on at this conference, start to think about things like security requirements for the defense industrial base and so on, are you seeing them thinking about the type of quantum challenges that we've discussed in this conversation?
Yes, absolutely. And in fact, NIST has a National Cyber Center of Excellence around post-quantum cryptography. And we're proud to be one of the consortium collaborators, along with many other very capable companies and technologies in the space. They're working to establish standards around discovery and inventory workflows, as well as the great work that they've already done in establishing new standards towards those quantum resistant algorithms, right? And helping defense industry, the Department of Defense, the federal government kind of find their way to solving this problem, which is not 10 years from now. In the industry, we think it's a now problem. And certainly the government needs to establish what they have, understand what's that most at risk, and start to get to a more quantum resistant future.
Aaron, it's great to have you here. Thanks for joining me.
Well, thank you very much, Francis. My pleasure.